In this video, I'm going to talk about complex numbers. Here, I'm taking two complex numbers. One is z1 equal to 3 plus j4. Okay, so here 3 is called a real number and 4 is called imaginary number. Okay, so the complex number, and 3 plus j4 is called complex number. It's a complex number. Now, for imaginary part, in mathematics probably you might seen I, but in this class I'm already using I for current, so to avoid confusion I'm using j. Okay, so you can write 3 plus 4j or 3 plus j4, anything is fine. Another complex number, I'm taking 8 minus j6. Okay, so j is the imaginary number and 8 is the real number, j6 is the imaginary number. Now, any complex number we can represent in two formats. One is rectangular form. In rectangular form, you will end up with real part and imaginary part, or plus or minus jx. And the second one is polar form. In polar form, you will have magnitude and phase angle. Now we're going to see how to convert rectangular form to polar form. So rectangular form to polar form. Most of your calculators will have this symbol R to P or P to R. Okay, so I highly encourage you to find how to solve it in your calculator. So here is the first example. I take a rectangular form. So z equal to 3 plus j4. Now I'm going to convert this into polar form. When I convert this into polar form, I will end up with magnitude and phase angle. So magnitude equal to z equal to square root of 3 square plus 4 square. That's the magnitude. And phase angle is tan inverse of always imaginary over real. Imaginary over real. Okay, so this value is 5 at an angle of 53.13. This is the polar format. Okay, this is polar format, this is rectangular format. Let me take this as z1. So z1 equal to 3 plus j4, which is equal to 5 at an angle of 53.13. Now same way, z2 equal to, I have 8 minus j6. So this will be z equal to square root of 8 square plus 6 square, tan inverse of imaginary, I have minus 6 over real is 8. So I'll end up with 10 at an angle of minus 36.86. So all I did here, I used Pythagoras Theorem, if you remember that. So here is the x-axis. If you take a coordinate system, the y-axis, we can take that as imaginary axis. So this is j-axis, that's a real axis, imaginary and real. So say 3 plus j4, so 3 is right here, 4 is somewhere there, so that's 4, this is 3. Okay, 3 plus j4. Now to get the magnitude, all I did, this is the Pythagoras theorem, square root of 3 square plus 4 square. So I'll end up with 5. What is this angle? This angle is 53.13. That's how I found that. And 8 minus j6. So here is somewhere 8. And minus j6 is somewhere here. Okay. So now if I multiply, if I combine these 2 points. Okay. So here is magnitude 8 square plus 6 square, and here is the theta. You will end up with a negative angle there since it's in the fourth quadrant. So the theta here is 36.86. Okay. Another way of representing, instead of writing in this format, in this line, usually we'll write this. This is your z1 at an angle of what is that angle? 53.13, and here z2 36.86. Okay, This is how we convert rectangular to polar. Now, how do you convert polar to rectangular? So if I have a function in polar, how to convert that into rectangular? So to convert polar format into rectangular format, so polar format is 5 at an angle of 53.13. So it is 5 cos 53.13 plus j 5 sine 53.13. Same thing here. If you remember the trigonometric calculations, say here is a 5, this is 53.13. Okay, what is sine theta? Sine theta equal to opposite over hypotenuse. Okay, so I have hypotenuse 5. What is the opposite? Can I write this as sine theta times hypotenuse? So 5 times theta is 53.13, so 5 times sine 53.13, and adjacent is nothing but cos theta. Cos theta is cos 53.13 is adjacent over 5. So to get the adjacent, 5 times, I mean hypotenuse times cos 53.13. That's how I found that those magnitudes. Okay, so this is the real part and imaginary part, I mean those numbers, and the 5 is the magnitude and theta is the phase angle. That's how we call them. Now we have two complex numbers. One is z1 equal to 3 plus j4. I have that as 5 at an angle of 53.13, and z2 equal to 8 minus j6, which is 10 at an angle of minus 36.86. Now, how do we add, multiply, divide, and subtract these complex numbers? First, we're going to see addition. Okay, when we add two numbers, let me call this as z total, which is z1 plus z2. If they are in polar format, that polar format is also called vector format or phasor form. Vector form, phasor form, polar form, these are all the common names. Okay, so when it is in the polar format or vector format, we cannot add these two. All you need to do is you need to find out x component and y component, which is rectangular form, and then add them. So 3 plus j4 plus 8 minus j6, which will end up with 11 minus j2. Okay, so to add two complex numbers, they must be in rectangular form, not in polar form. Now subtract. So subtract, I'm going to say z total equal to, let me take this as z2 minus z1. Just I'm taking randomly. There is no reason I'm choosing z2 here. Z2 is bigger, so that's the reason I'm choosing that. So 8 minus j6 minus 3 plus j4, so we'll end up with 8 minus j6 minus 3 minus j4. So add the real part, which is 8 minus 3, which is 5, and add the complex imaginary part, so 5 minus j10. This is subtraction. Same thing, you cannot do two quantities when they're in, I mean you cannot subtract two quantities when they're in polar format. You need to convert them into rectangular format and subtract those two. Now the third one is multiply. Okay, multiply. So let me take this as z total equal to z1 times z2. Okay, so I'm going to do the rectangular format first. So I have 3 plus j4 multiply by 8 minus j6. So we can multiply 3 times 8 plus j4 times 8 plus 3 times minus j6 plus j4 times minus j6. Okay, so one important thing here, which is minus j square is nothing but 1. Okay, at the same time 1 over j, I can write this as minus j. Okay, so these two are the important things here. So 24 minus or plus j 32 minus j 18 minus j squared 24. So as I mentioned, minus j squared is nothing but 1. So 24 times 24 plus 24, 48 plus j 18. Okay. So when you multiply two complex numbers, when they're in rectangular form, it's a little bit difficult, I mean lengthy process. I'm going to do this when they are in polar form, z1 times z2. When they are in polar form, I have 3 plus j4 as 5 at an angle of, so 3 plus j4, 5 at an angle of 53.13, and 8 minus j6 as 10 at an angle of minus 36.86. Okay, so here when we multiply this in polar format, multiply the magnitudes, so 5 times 10, which is 50, and add the phase angles, so 53.13 plus minus 36.86. Okay, so it's 50 at an angle of 16.27. Okay, so if you convert this into polar format, you will end up with the same thing, 50 at an angle of 16.27. Now I'm going to do the division. So in division, let me do z2 over z1. What we have, z2 equal to 8 minus j6 over 3 plus j4. So here 8 minus j6 over 3 plus j4. Now to do the division, what I'm going to do, I'm going to multiply and divide this with complex conjugate of the denominator. Conjugate is nothing but 3 minus j4, 3 minus j4. So when we say z1 equal to 3 plus j4, conjugate we indicate with a star, okay, up to the power star, and we call this as z to the power star, and it's going to be 3 minus j4. Okay, say if z equal to minus 2 minus j4, then z conjugate is nothing but minus 2 plus j4. That's how the conjugate is only the sign of the imaginary quantity is going to change. Okay, now so here in the denominator I have a plus b and a minus b, so 3 square minus j4 whole square. So I will end up with 3 square is 9, j square minus j square is positive, 4 square is 16, so it's 25. So same thing, 8 times 3 minus plus minus j6 times 3 plus 8 times minus j4 plus minus j6 times minus j4. Okay, so 24 minus j18 minus j32 minus plus, but plus j square 24. So we end up with 24 minus 24, so j square is nothing but negative 1. So these two get cancelled out. I'll end up with minus j50 divided by 25. This is minus j2. Okay, and it's a little bit complicated one. If I do this by using polar format, z2 over z1, so 10 at an angle of minus 36.86 divided by 5 at an angle of 53.13. So just divide the numbers 2 and subtract the angles, 36.86 minus 53.13. You will end up with 2 at an angle of minus 90 degrees. Okay, so minus j2, can I write this as, since the real part is missing, can I take that as 0? 0 minus j2, when you convert that into polar format, you will end up with 2 at an angle of minus 90. That's what it is. And I mean, if you look into the graph, okay, minus j2 is somewhere here, isn't it? So it's exactly on the y-axis. So can I say in polar format, the length of this line is 2 and it is making 90 degrees to the real axis. So that's how you can read. Okay, this is how you deal with the complex numbers. Thank you.